A telescoping series is a specific series that is not commonly used, but it will show up. So it's good to know what that looks like. So this series here is 1 over n times n plus 1 series. Now, we could actually show that this converges by doing a comparison with Basel series, or 1 over n squared, because it is essentially a quadratic in the denominator, which means it should behave like a 1 over n squared series. However, this one is unique in that we can show that it telescopes, okay, or it collapses. The series collapses from 1 to infinity, and we can actually work out a sum of this. So this is one that the sum can actually be calculated. So we're going to do this by, first of all, splitting this up into partial fractions. So when we split up into the partial fractions, I'm going to solve for a and b. So I'm going to end up with a times n minus 1, n plus 1, plus b times n, bn. And we can equate the coefficients, so we know that a plus b is equal to 0 because we have 0 n in the numerator, and we also then can see that a is equal to 1. Okay, so that's our second equation, because we know that a times 1 gives us a constant, and there's a constant of 1 in the numerator. So then if a equals 1, b equals negative 1. Okay, so when we decompose this then, we can see that we end up with 1 over n minus 1 over n plus 1. So these are equivalent. And when we actually expand this out, we're going to get this expression here. So this, instead of using the 1 over n plus 1, we're going to use that, and we're going to express our partial sums like this. So it's going to be, we're going to plug in 1, we're going to get 1 minus 1 over 2. When we plug in 2, we get 1 half minus 1/3. When we plug in 3, we get 1/3 minus 1/4. It just continues all the way to 1 over k minus 1 minus 1 over k. Then the next term is going to be 1 over k minus 1 over k plus 1. And you should notice that the consecutive terms of the sequence, those two terms are going to cancel. One is minus 1 half plus 1 half. Minus 1/3 plus 1/3 are going to cancel out. This is going to cancel out. These consecutive terms will cancel out. These consecutive terms will cancel out. This one cancels out with the none next to it. So what ends up happening is all these terms disappear. So this disappears, this term disappears, these terms, and all we're going to be left with is the starting 1 plus or minus the 1 over 1 plus k, and then we can just find the kth term, or let k go to infinity, and we're just going to end up with a sum of 1. So this series is a telescoping series because it collapses because all those middle terms cancel out. And this is a unique series in that we can actually work out an actual sum. So remember that most of these series, the sums were hard to work out. This telescoping or collapsing capability of this series allows us to actually work out a sum. So this doesn't show up very often. We don't use this very often, but it is a useful thing to know, because when you see it, you can see how, first of all, we can show that it is convergent, but we can also, this is a very useful technique to be able to actually calculate sums, because in this case, we actually worked out the sum of this series to be equal to 1.